Hello and welcome back to this channel. Dear students, today's topic is aviation and marine communication system. Presently, we are talking about aviation communication system. So, this type of communication, as the name indicates, it is aviation communication. That means it is a wireless communication that is used between aircraft and ground control stations. It makes use of high frequency or very high frequency range, and in this case amplitude modulation is used. So this is the corresponding block diagram. The first block is microphone. Whatever pilot speaks, that speech, that audio signal is captured by the microphone and it is converted into electrical signal. Then this signal is usually weak, so to amplify that audio signal, audio amplifiers are used. Then output of audio amplifier is given to the RF transmitter. The major function of RF transmitter is to accept audio signal output from the audio amplifier and convert it into RF electrical signal, as well as it provides modulation. As I said, it provides amplitude modulation. So even if there is a overlapping of signals, using amplitude modulation we can identify the proper signal. Then output of this RF transmitter is given to the antenna. As we discussed in earlier block diagrams, this is the transmitter side. So function of transmitting antenna is to accept electrical signal and convert it into electromagnetic waves, that is EM waves. These waves travels through the free space. Then this is the receiver side, lower part is the receiver side. So receiving antenna performs the reverse operation. That means it captures incoming EM, electromagnetic waves, and converts it into electrical signal. This output of antenna, receiving antenna, is given to the RF receiver. So we discussed the function of RF transmitter. RF receiver captures or identifies a particular received signal and it performs the demodulation operation. We discussed that in case of RF transmitter, especially in VHF range, very high frequency range, AM, amplitude modulation is preferred. So demodulation is performed by this block. Then still its output is low, so to amplify that signal, audio amplifiers are used. Then output of audio amplifier is given to the speaker or microphone. So this is the corresponding block diagram of aviation communication system. Now important features of this aviation communication are: it is a reliable long distance communication system. Then fast information transfer can take place, especially in case of landing or while takeoff of the aircraft. Then continuous aircraft monitoring is done by making use of this system, and it supports emergency communication. The different applications are air traffic control, that is ATC, then aircraft navigation, then weather reporting, and pilot ground coordination. So this is about the aviation communication system. Now let us discuss the block diagram of marine communication system. It is very much similar to the aviation communication system, apart from some major changes. What we discussed in aviation communication system, it is used for aircrafts, whereas this marine communication system is used in case of ships. So the communication in aviation system takes place through the free space, whereas this communication takes place over the surface of water. Now the block diagram is almost similar. This is the microphone at the input side, which captures captain's audio signal. Then it is applied to the audio amplifier. As we discussed earlier, that function of audio amplifier is to boost, to amplify the signal and provide the required strength. Then RF transmitter is used. In this case, the function of RF transmitter is to generate the RF carrier signal and provides modulation. That means it modulates the audio signal. In this case, in case of aviation, we discussed mainly in VHF band, amplitude modulation is used, whereas in this case, FM, frequency modulation, is used for short range VHF, and SSB, single sideband, is used for long distance high frequency communication. Then output of RF transmitter is applied to the antenna. The function is very much similar. It captures electrical signal, converts it into radio waves. These radio waves are allowed to travel over the surface of water. Then at the receiver side, this antenna captures this incoming radio wave signals, converts it into electrical signal. The function of RF receiver is exactly in a reverse way as that of RF transmitter. It captures the received signal and then demodulates the signal. Still its output is low, so to improve its output, audio amplifier is preferred, and finally output of audio amplifier is given to the speaker or microphone. Some important features are: it is applicable for long distance communication, it is useful for navigation systems, then it is a very much reliable communication over sea routes and supports weather updates. Applications: the major applications are: it is used for the communication between two ships, so ship to ship communication, then ship to coastal port communication. Now let us discuss some important differences between aviation and marine communication. We'll consider different parameters. First parameter: aviation is used in aircraft communication, then this marine communication is used for ships. The type of communication: aviation is between air and ground, whereas this marine communication is between ship to ship or between ship to the shore. Then frequency band: usually VHF is used, that is VHF air band for aviation, whereas marine VHF for marine communication. Then type of modulation: in aviation is mainly AM amplitude modulation, whereas in marine it is FM frequency modulation on a single sideband. Frequency range is 118 to 137 megahertz for aviation, whereas for marine it is 156 to 174 megahertz. Major applications is air traffic control, whereas in this case it is mainly used for ship navigation. So this is about the comparison between these two systems. So dear students, that's it for today's session. So thank you. Thanks a lot for watching this video.